This is CPE 133. This is experiment 6, and what we're going to implement here is a 5-bit magnitude comparator. So overall, this is your first really non-trivial circuit, and it requires interfacing with a bunch of new modules, and not a big deal. Typically, anytime you're doing digital design, you are kind of using pre-designed modules, and that's what we will be doing in this experiment. So it's essentially implements a 5-bit magnitude comparator, which the implication here is that we're using, the inputs are signed numbers. Now the previous comparator we designed, the implication was it was unsigned numbers. We didn't really state that, but that's the issue. But if numbers are signed, that means we can take the magnitude of them, and it makes for a more interesting problem. And eventually we're going to verify the circuit works by just visually verifying it. So the magnitude comparator compares two 5-bit signed numbers. The signed values are in, of course, radix complement or 2's complement form. So the issue is there's a couple new modules here, and particularly this universal 7-segment display module. Now I can't tell you exactly how this works. It'd be beyond you, but you can go look at the code. But the issue is in the header of this module, it's going to tell you how to work the module. We'll come back to that later. Essentially what this is going to do is allow you to display negative numbers, and it's also going to allow you to determine whether numbers are valid or not. And so additionally we have an RCA that's provided for you. Don't use your previous ones. There's actually an n-bit RCA here. Don't modify it. When you instantiate it, you can instantiate it to any width you want, and so you'll need a replicator adder in this experiment. Now the issue with the 7-segment display module is it allows you to pretend like there's different values on the different 7-segment displays at different times, and it's actually not. It actually relies on retinal persistence to give it the illusion that there are different things on the displays at different times, but they're really not. It does it so fast it just appears that there are. And so this is what that universal 7-segment display module does. Essentially it's what we call multiplexes the displays. So this is the universal 7-segment display module. There's a bunch of inputs here, and then the outputs are the segments and the display enables. The issue is generally you can put in 2 values on this thing in one of the modes. Typically we're just going to put in 1 value, and it can be up to a 14-bit value, because up to 14 bits you can still display it on 4 decimal digits, which is 9999. So it does have an input to indicate whether the number you're putting on there is valid. You can turn on the decimal point or not. You can adjust the decimal point. You can declare a signed number. It runs in 3 different modes, so you have to select which mode it runs in when you instantiate it, and that's about it. This is, once again, I can't tell you exactly how this works at a low level, but I can tell you how it works at a high level. All the information's in the file banner, so read the file banner for details. So the approach you're going to take on this is to design this on paper first, and what you're going to do is just drop down your modules, define your modules. What the approach is, you're going to try to use every provided module or modules you've designed in the past, and what you're going to do is plop those down, connect the data paths. That's how the data is passed between the modules, and then connect the control signals as needed. There's going to be some special stuff you need to do with control signals. Now the issue in this is it is doing magnitude comparison, and what you're going to have to do in this thing is utilize the signed bit and the valid bit on that universal 7-segment display. Now this is kind of tricky. I would suggest using brute force design in this, which essentially set up a table to output the correct stuff based on what the experiment is asking you to do. So keep these modules as simple as possible. You don't really need any new modules for this. It's just a couple maybe one logic module, or you can implement it as logic. But the idea here is, in any digital design, use a bunch of simple modules rather than one complicated module.